We are now going to talk about inheritance. Inheritance is a very important concept of object-oriented programming because it provides us with the capability to extend existing functionality. We're not always starting from scratch, we already have something, and then we're going to build upon it to provide more customized behavior or new added functionalities. You can start thinking of inheritance as you would think about when it comes to its English meaning, is generally associated with transferring of wealth. So it's parents transferring over the wealth to their children, or the children are inheriting the wealth from their children, from their parents. Similarly, in computer science, the concept remains the same. The subclass, the class who is inheriting, inherits the wealth from the superclass. The wealth here, though, is not in terms of money, but it's terms of knowledge. So the superclass has a wealth of attributes and behavior that has already been implemented, and the subclass wants to build upon it or customize some of that behavior for its need. So it's actually inheriting from the superclass to add on or to add on, extend, or modify those functionalities. You can start thinking by considering an example. Say were implementing a simple basic calculator. When you start with a simple basic calculator, you added the addition, subtraction, multiplication, and division functionalities to it. But then when you want to go about and start developing advanced scientific calculator, you don't want to start again from scratch. You don't want to write those functionalities again, those already exist. So you will probably create the advanced scientific calculator class, and your advanced scientific calculator would extend from the basic calculator and implement the functionalities which are not really present. You can also inherit in certain examples to actually go forward and tweak certain functionalities that are present. For example, if a class basically represents a car and it has the accelerate, brake, and turn features, and you are now introducing a new functionality, and you basically a test line, you're defining, okay, the brakes are going to work in very different way in my particular car, but accelerate and turn are going to be more or less the same. Then you can inherit from the class and just override the implementation of brake to provide your own specific implementation. And we're going to look at some examples to cover those items. Now, let's go forward and read the definition of inheritance. Inheritance: a class can inherit method properties and other characteristics from another class. When one class inherits from another, the inheriting class is known as subclass, and the class it inherits from is known as superclass. Inheritance is the fundamental behavior that differentiates classes from other types in Swift. And what we're trying to identify here is that if you're working with like structs and enums in Swift, that those do not support inheritance. Classes do support inheritance, and it's a very powerful feature to have. And you will see that inheritance is used in a lot of places in iOS programming. When you start using UIKit and you look at your controllers being written, they all inherit from UI view controller. They don't really use structs as UI view controller and then expect you to provide extensions for the same. They simply have classes, which is UI view controller, and they allow you to inherit from those classes and then provide customized behavior. And that will come later in this course when we talk about iOS programming. But let's start looking at some examples. And as we look at the examples, there is one important thing to take note of. In inheritance, there is a lot at play with access specifiers. We will use a bunch of access specifiers. We'll use private, file private. We'll use public, we'll use open. We will have the default, we'll have the internal. And as we go over the examples, I'm going to cover each one of them. So let's get going. As always, I've created the playground page, which is inheritance. It has its sources folder. There's nothing in there. So let's go forward and create a new file. And I'm going to call it the lang. I'm just going to write an example. And in our example, I'm going to start thinking about computer languages. So I'm going to find a parent class which has computer language, and then it has some behavior like it can do checks for whether the language can be compiled, cannot be compiled, on how to do syntactic analysis for a particular language, what checks it perform during compile time, and then allow a bunch of classes to inherit their functionality. So let's get started. First thing, we start with the class definition, and our class is going to be computer language. Awesome. Now, in my class, I'm going to define a variable, and the variable is going to be language name. So that's the name of the language I'm actually dealing with. So yeah, every instance of a computer language can have a different language name. Now, the second option which it can be present is to have a variable, which is a Boolean, and saying that whether the language is compiled or not. Okay, so we do that. And so I've got two variables at present inside my class. Now, these variables basically are non-optional. So I do need an initializer in my class. So I go forward and add an initializer, cell.language name, and default probably to nothing. And is compiled, I'm going to default to no. Okay, I'm going to start with no. And if there is something which is going to be compiled language, someone needs to explicitly set it. All good now. Now I'm going to have a child class, and the child class I'm going to take Swift. The child class is going to be a child of computer language. And the way you do that is you specify a new class, and after the colon, you actually specify the name of the parent class. So you go forward and do that. And here you need to now decide what all variables you want to override. And you can override any variable. These are defined at the top. Um, but at the same time, you can actually inherit all the initializers which are defined at the top. So you don't necessarily need to do a lot of stuff. Like say, by default, as you look at it, this code compiles. It does not complains, it does not errors out, but the code actually compiles. So let's go forward and look at another child class. And this time I'm going to define Kotlin as a second child class. And this one is also going to extend computer language. Okay, now we'll start by adding some functionality into each one of them. First one, in my default computer language, I'm going to define a function, and I'm going to say this is a function which is going to do some syntactic analysis. Okay, do syntax validation. Okay, so I'm doing some syntax validation, and yes, I'm not going to worry about writing a new compiler altogether. I'm just going to print a statement here. Completed syntax analysis for language name, right? So I know that. Now, in the child class for Swift, okay, it inherits these attributes, it inherits these functions, so all good and dandy till now. What's missing is the fact that I have not set that it is compiled or not. So do I need to wait for some function to be called inside Swift to set that it's compiled or not? Or should I define my own initializer? I can definitely define my own initializer, and I don't need to do something very specific. I can just go forward and define my initializer. And if, let us say, this initializer was doing something unique, then I can go forward and call this parent class by using the keyword superclass. And since I have the same signature as the initializer in the parent, I will have to specifically use the keyword override. Otherwise, I will get a compile time error. I have to explicitly state this, that no, this is not an accidental mistake that I'm using the same method signature as the parent class. I intentionally want to override, and then it's going to allow for overriding to actually occur. All good. Now I'm going to go forward and call super.init, and then I'm gonna call self.language name as Swift, and I'm going to have self dot is compiled as true. Okay, so I did change the default values. One important thing to note is that you can say that, well, I went in and initialized both the variables in here with new values, and the parent initializer was not doing anything. So can I just go forward and remove this line for super.init? No, you cannot, because Now you're trying to refer to self without the super.init being called, while the compiler knows that there is a parent initializer which is actually present. So the self has not been created yet. The self needs to be created, so that is why you need super.init to be called before you start using it by using the object instance by referring to it as self. We're going to do the same thing for Kotlin, and it is also compiled. And in Kotlin, I'm going to override some syntax analysis validation. Actually, it's a Swift course, so let's go forward and do it in Swift. Okay, custom syntax analysis for a certain language. Okay, now again, it's a function which is present in the parent class, so I have to explicitly state that, okay, I'm overriding this function. All good and dandy. Now, this actually demonstrate, okay, that I had the superclass or the parent class, which is computer language. I had a bunch of attributes, and those attributes are visible in the child classes, all good. Then I defined some behavior, which is do syntax analysis. That behavior is, we're going to check, is going to be available in the child class. And we can choose to override specific behaviors and specific attributes as desired. All good. In these classes, Swift and Kotlin are called the child classes, and the computer language is called the parent class. Can I go forward and define multiple inheritance? Can I have Kotlin inherit from computer language and Swift both? No. Multiple inheritance is not supported by Swift, just like other programming languages like Java and Kotlin, and unlike C++, which does support multiple inheritance. Now, important thing to notice that the sources that you write and the sources directly on a playground page is eventually compiled and made available to your page as a module. You don't necessarily need to write the import statements because it's imported by default, but under the hood, the lang.swift file is actually captured, converted into a module, and the module is being made available. And this is the important point because when we start talking about access specifiers, you will see the implications of this. Now in here, I'm going to go forward and define an, a variable Swift, and I would want it to be an instance of the Swift class. So I went forward and defined Swift. So I got Swift back in handy now. Now, when I do so, it immediately errors out and says that, okay, you can't instantiate it. And like, okay, why? So I go back to my language class and say, okay, couldn't I have done that? And you go in and you put the code here and don't get any compilation error. It's a legit piece of code. So why can't I call it? Now going back to the discussion, Swift compiles lang.swift as a different module. Now all the classes I have defined here, these classes are defined by default scope, and the default scope is only visible in the same module. The playground page is importing the lang.swift module, but it is not part of the same module. So it does not have visibility into these classes which I have defined. So if I really want these classes to be visible outside, I need to go forward and change them to have public scope. So I'm going to change this to public, and it's still going to error out. Okay, so I'm going to go forward. Um, is superclass, okay, sorry, I did not change the superclass to public. So now I went forward and defined both the parent class and the child class to public. Now I'm still going to get an error. And the reason I'm still going to get an error is because it's saying that, okay, well, yes, the class is public. I can see the class, but the initializer is not public. So I need to come back in here. And then I have, while saying override, I have to say that, okay, my initializer is public. Now, when I do that, I go back in here, and what you will see is the error has disappeared. I'm able to go forward and instantiate the Swift class now. Can I call it functions? Let's say Swift dot nothing, because again, it's going to the same problem. It's part of the module. The function is not public, so no one can actually go forward and see it. So I have to go forward and make the function public if I really want this function to be visible in inheritance page. So now if I press the dot operator, you can see the function and you can invoke the function and it shows you its custom analysis results. Now let's look at some of the things. If your class is public, okay, then as you saw, okay, your parent class cannot be just internal scope, it has to be the same scope, but you can do the reverse, which is your parent class may be public, but your child class can have just the internal default scope. So that is allowed. Kotlin at present is visible only in Lang or Swift, but it is not visible here in the playground. So I can't call Kotlin, I can't call its constructor because its scope is restricted. All good. Now, let's start by doing some differences. Okay, so the first one we're going to look at is what's the difference between open versus public. I just showed public, and it totally makes sense. When I make something public, it's available outside the module, so I was able to use it. All good. Now, what's the difference between open and public? They both seems to have the capability to make themselves visible outside. So let's take an example here. I'm gonna make Kotlin public here as well, okay? And I'm gonna make his constructor public as well. So everything is public. Now I'm going to change Swift to open from public, okay? So this is open. But as soon as I do that, I get the same error. You cannot go forward and down scope or increase the scope in the child class. You can only down scope. You can go forward and the parent class can have a larger scope. You can restrict the scope in your child. But you cannot go and increase the scope in the child class because by default, if you are just allowed to increase the scope in the child class, what you can do is that, for example, this is public. I can go forward and say open class and I say Swift hack extends Swift. Okay. So what I could do is that I basically went forward and defined a new class in this scenario and they made it open. So it's available to be inherited outside the module while the parent class was not intending it to be able to do so. So as a result, I have been able to access all the variables and attributes and now making them public, but just introducing a newer type and not adding any functionality. And that's what we want to restrict, which is why you cannot go forward and increase the scope of the access in the child class, but you can decrease the scope of access in the child class. So let's go forward. Let's say that, okay, these are the three classes. They are all public for now. And what I'm going to do is that the Swift one, the computer language one, I'm going to have open so that my Swift can become open. So all good. Now, these two classes are open. Kotlin is public. Let's look at the implications. Can I go forward and call the Swift class right now? Yes, I can. I can go forward and call the Swift class just fine. There are no issues. And still executing. Okay, let's try and do the same exercise for Kotlin. Okay, so let's go forward, try and execute Kotlin. Can I call it? And I can call Kotlin, but I don't have any implementation in there. And the reason is because even it does not have a method in the first place, but the parent class has a method, but that's not public. So it's not visible inside Kotlin. I'm going to make this parent function as public for now, so as to have some function made visible in Kotlin. So I come back in here, I say, okay, and now I see the function, I call the function, but this will be the default implementation. So you can see that the custom syntax analysis and complete syntax analysis for Kotlin, which is inside the parent. Let's change it to default so that it's easier for us to comprehend. But all the functions and behavior, as I told earlier, are available to the child classes. Okay, goal is going there printing it. Okay, so what is the difference? Both of them allow it to be accessed outside. The difference comes when you want to do something like this. You went to the class and you said it is Swift version 4. I'm gonna release that, or version 5, let us say, and it's gonna extend from Swift. Okay, and it's allowing me to do that. There are no compile time errors. I can very well go forward and do this exercise. I can even go forward and call the override operator and then go forward and say super.init and then change the initializers to anything like language name. if I want to. But again, before I do that, these variables have to be public. They are not public yet, so I can't access them. I'm outside. So I went forward and made them public. And now I can come back and say language name, and I can change it to Swift 5. Okay, cool. So now I can go forward and instantiate Swift 5, all good and dandy. So I will have Swift 5, Swift 5, and Swift 5. When I try and run it, I should see that, okay, everything runs 5 for Swift 5, all good and dandy. Now let's try and do the same exercise for Kotlin. So I'm going to define Kotlin, and let's say Kotlin to Kotlin, and pretty much doing the same thing which I did for Swift. And I'm not allowed to do that. Okay. And the error says that I cannot inherit a non-open class because it's outside of its defined module, and that is the difference between open versus public. If your class was open, then you can go forward and decide to inherit that particular class even from outside the module. You don't need to be necessarily inside the same framework, same module before you can go forward and extend that particular class. But with public classes, the restriction is that you have to be you go forward and use these classes, but you cannot inherit and add behavior in your own custom implementations for those particular classes. But you can go forward and invoke those classes. You are able to actually simply go forward and use the initializers and the behavior which is defined. You just can't extend it unless these classes were open enough to the idea of you modifying their behavior. So classes have to be open for you to modify the behavior. Classes have to be public for you to be able to access and use them. Okay, important. Now let's go back, and I think I already touched upon some of these pieces when I talked about internal. But we're gonna now talk about is the internal and the default access. And what's happening here with the internal access is that it's actually internal to the module. So if there's a need where you want to define a certain level of access, which is only internal accessible within the module, you can use the keyword internal. And with that particular keyword, which is internal, you can go forward and access that particular function everywhere inside or behavior inside the module, but not outside. So let's go forward and define internal func do some internal analysis. Okay, so I went forward and defined a module. I said, okay, it's going to do some internal analysis, and then I'm going to say print and doing internal analysis. Okay, done. Now let's see who all can see this function. Okay, so I can go forward and see this function in the Swift implementation. I can say super dot do some internal analysis. Okay, all good. I can see that. I have another class present here, which probably can go forward and try and override it. Override function, do some internal analysis, doing Kotlin specific analysis. Okay, all good. So I went forward and did that. And this time I basically didn't go forward and define the scope again. I didn't went forward and define the internal scope, but I didn't define public as well. So it's defaulted. So I'm actually going to go forward and define public scope for the child method. Okay. And it's overriding the parent method, defining child method. I'm going to remove this compile time error so we can actually move forward. Now let's look at the Swift 5 implementation. Let's remove this as well for clarity purposes. And let's keep this one and move on to private. Okay, internal. And now I have a Swift handle which is already available. When I go forward and call Swift and say, check, okay, I do syntax analysis, but where is my do some internal analysis? And again, it was available in the child classes inside the same module, but it is not available to anything outside the module. So you are not seeing when you use a dot operator, the function for do specific or do some internal analysis from outside the module. It's internal. But then I went forward and defined it as public for Kotlin. So let's try and see if that one works. Kotlin dot, and there is do some internal analysis implementation which is available, and it is doing some internal analysis and printing the statement up for me. So um, I can override the implementation of the parent classes in the child classes with an override function, and then go forward and print or do or increase the scope. Like instead of having just internal scope, I increase the scope. I'm not allowed to do that for classes. Classes can only reduce scope. But for functions, I can actually expand access. And the reason is that because I may intend to use the same function name, but do totally something different. For example, here, I decided to use the function name, which is do some internal analysis, but I'm doing something totally different, right? I'm not doing exactly what was being done earlier. So I'm adding functionality to that, and that added functionality I want to be made available outside. So that I'm still allowed to do. Cool. Now, another item to actually view here is that if I go forward and remove these pieces of code, okay, now I'm doing some syntax analysis. Oops, it's Kotlin. So I can't remove this piece. I'm gonna remove these pieces. So I'm doing some syntax analysis on Kotlin. Okay, so I did some syntax analysis. So I'm getting this internal analysis primarily because I'm pretty sure I'm calling this function from the Swift implementation. I'm gonna remove that so that it doesn't cause us any confusion. Now when I look at it, oops. Now when I look at it, I see basically the calls for, okay, I'm doing some custom syntax analysis, I'm doing some default syntax analysis, and I'm doing some Kotlin specific internal analysis. All good. But you can clearly see that even though it inherits from the parent class, it's not printing doing internal analysis. And the reason is that you have overridden the functionality. If you want to keep the parent functionality and add to it, you can do that. You can simply call is not self, sorry. If you call self, you can go to infinite loop. You can call is super dot do some internal analysis. So in here you're saying that okay, yeah, yes, I want to provide some of my implementation, but before I do so, I want to call my parent and then go forward and execute the functionality which is present in the parent. So get some values out of it and then come in here and go forward and execute syntax analysis. When I do that, now you can see that doing internal analysis gets printed again because the super do some custom or internal analysis calls the internal function first, executes it, and then goes forward and executes the child. So that's how internals are handled. We're going to talk about private and file private now. Private and file private, and see what are the differences between the two. Let's go forward and see our example again. And here everything was actually public for now. And I'm going to go forward and define a private function. Okay, do something private. And it's going to say private function. Okay, call. Okay, simple. Now this is a private function. Once it is private, then no one has access to it. Okay, so not even the child classes, only the same class has access to it. So if I'm doing some syntax analysis, I can definitely call self dot do something private because within the same class, the private functions are visible to me, so I can invoke them. But if I go back to one of the childs and I try and do something like super dot, no, I can't see do something private. Can I try self dot and see? I can't see because they're children. They cannot see the private content that is only relevant to me. The private portions, as the name suggests, are not visible even to the children. And of course, even though if they're not even available to the children, forget about those items actually being visible to anyone which is outside the module, right? We're not even talking about, we're talking about now controlling access within the module. So anyone outside has no access to it. The last piece, which is file private or the access specifier for it, is also an interesting access specifier because what it says is that, well, there are times when there is a need for certain function, behavior, or attributes to be visible to the same file, not to the entire module, because when you start talking about the entire module, you're talking about internal scope at that point in time, which is you can have 10 files in the module and all 10 can access something which is internal. But we're not talking about internal, we're talking about something which is uh, accessible only to the same file. So lang.swift is one file. If I want every class, every function, every struct, every enum, every extension which is written in the same class to have access to this function, but no one outside, then you can go forward and define it as of type file private. When you do that, suddenly this is still private, so I can go back and try and see if, okay, can I call Swift dot do something private? No, I cannot because it's still not visible. I come back in here and in my Swift syntax analysis, I try and say is self dot, and I can see do something private. And when I come back here, whoever is calling me should be able to call the private implementation and private function gets called because this function is private, but it's visible now to the entire file. It's not a private to the class, it's private to the file. So as long as you're in the same file, it's all good. And the reason why this file private actually exists in Swift is that in Swift, you will be using protocols, structs, extensions a lot. And you want even your private functions to be sometimes available as long as it is written by you. The code is written by you. Because extensions can be overridden by any developer from outside the code base as well. Um, you really do not want certain functions or attributes to be visible to them, but you want to be available and visible in case it's you who is writing them. So that's where file private actually comes in very, very handy. Um, Another good note to note here is again, this inheritance is actually supported only by classes. And of course, you can inherit protocols as well, but this not actually uh, supported by structs. Structs do not support inheritance. And if your question is that, well, that's a big limitation of structs, then why did Swift decided to actually go forward and define the integers, strings, doubles, everything as struct instead of being a class. And there is a way around it. So what Swift is saying is that for integers, strings, and doubles and all those data types, you all you want to do when you're extending something is to add behavior. You're never actually trying to add new stored variables or stored types in those scenarios. So as a result, structs is an ideal choice for them because with structs, you can add functionality. You cannot override functionality. You can add functionality using extensions, and that's what Swift wants to do in those scenarios. They have provided some behavior. They do not want you to override it. They want you to be able to still add behavior to it, and that you can do using extensions, and that will be covered when we talk about extensions. And that's all you need to know about inheritance.